Okay, this is our final unit on circle geometry. It's 10.3 and has to do with tangents to circles. The first question in our assigned 13 says, Raven and Elliot are discussing the diagram shown. Elliot claims the line AB is tangent to the circle because it touches the circle in one place, which of course, right there would be where it touches the circle. But Raven disagrees. Who is correct and why? Well, in order for a line to be tangent to a circle, it has to have two properties. It has to be outside the circle, which is the first one, which I guess technically this part of the line segment is outside the circle, but the whole line has to be outside the circle and has to touch at one point. It touches the circle at one point, which this does. And the other one it has to be is it touches it perpendicularly, which of course is a fancy word for 90 degrees. So in order for AB to be tangent to it, it has to be outside the circle and meet the radius, which is not even drawn there, at 90 degrees. The second question says, if BC is the radius, and is AB tangent to the circle? This is probably the easiest question in the entire set. It does touch it at B, but in order for it to be tangent, it can't be 85 degrees. It would have to be 90 degrees. And interestingly enough, if I was to draw a circle, if I was to use my little tool here and draw a circle and take a line, and I was to make it touch the radius perpendicularly, if I was to start closing this line off, and I think I can close it, as I start making this angle less than 90 degrees, so if I start at 90, touches at one point, as I go through turning it inwards, I'm actually touching the circle at 2 points. So even though we can't see it because it doesn't look it, if we were to zoom in, as soon as I move that into 89 degrees, it would indeed be touching the circle at more than 1 point. And we can only see that if we go to like 40 degrees, we can see it touching at 2 points, or at 25 degrees or wherever, we see it touching at 2. So at 90 degrees, it touches at 1 point. Anything less than 90 degrees, it would be touching the circle at 2 points. So that's another way you could say, explain that the line is not that it's not tangent. In the next question, question 3, I think. Question 3, in the diagram, AB is tangent to the circle at point A. I think we already did this one, but we'll go through it again. So as it says this statement right here, and I'm trying to get you guys to do this, when it says this statement here, the first thing you should do is find point D, find AB, and since it's there, I'm going to put a little 90-degree angle right in there because it is tangent, okay? And then it says BE contains the diameter. BE contains the diameter? Where's BE? Oh, BE. BE is the diameter right there, and ABE is 60 degrees. So here's the following question. So the first thing is, what is the measure of BDC? BDC. And like I said, because I highlighted it in yellow, it's 90 degrees because it is tangent. Question B says, what is the measure of the central angle DCE? So DCE, what is the measure of this angle? And this is going to take a little bit more logic. It doesn't say find DCB first, but in order to do that, you first need to figure out that little dot angle first. And the reason why we can do that is because we have a triangle. This is 90. This is 60. And we know that all three angles have to equal 180. So those two here equal 150, which means this one here is 30. So that little dot angle is 30 degrees. And since BE is a straight line, and a straight line is 180 degrees, 30 plus the remainder would be the 180. So that angle DCE is 150 degrees. And that's based on the fact that straight lines are 180. And those two angles, BCD and DCE, are supplementary or add up to be 180. What type of triangle is triangle CDE? So what type of triangle is CDE? So I'm going to trace it out. CDE is right here. What type of triangle is that? The answer is isosceles. And we know that because this is a radius and this is a radius. And when two sides of a triangle are equal, it's called an isosceles triangle. And the final question says, what is the measure of angle DEC? So DEC means what is this angle right here? And if we redraw that equilateral triangle. We already knew this one here because we already wrote it down as being 150. And we know that it's equilateral. And one of the rules of equilateral triangles is the base angles in equilateral triangles are equal. And since 150 is one part of the three angles that add up to be 180 degrees, these two angles here have to add up together to be 30 degrees, which makes each of them 15 degrees. So the angle ECE is 15 degrees. Question 4, it says line segment JK. So I'm going to just do it in black here. Line segment JK is tangent to the circle at point H. So right away, the first thing I'm going to do is I'm going to put a 90-degree angle right there. I know that that's going to be a 90-degree angle, and so will the other side of it be, but I know that I'm only going to use that 90-degree angle because I see a triangle already. I see two triangles, actually. GH is the diameter, and CGL is 10 degrees. There it is there. Justify your answers to the following questions. What type of triangle is CGL? So I'm going to type CGL. What type of triangle is that? The answer again is isosceles. And the reason why is because it has two radiuses. And I'll draw the radius here and here. Those are two radiuses, which makes it an isosceles triangle. What is the measure of angle GCL? So GCL. I'm going to redraw this triangle here. Now we know this is 10, and we know this is an equal. This is what we have for information of this triangle. Since it's an isosceles triangle, this one over here will also be 10 because it's a base angle. Those two add up to be 20, which means since all three angles have to equal 180 degrees, this top angle must be 160. And if we think about it, angle GCL right here is therefore 160 degrees, based on the fact that it's an equilateral triangle. What is the measure of JCH? So what is the measure of this one, where that dot is? What is JCH? Again, GH is a straight line. So if I draw it here like this, and I have this angle right here as being 160, right, where this one here is, that's 160. This angle must be the remainder of the 180, which makes angle JCH 20 degrees. So this one here is 20 degrees. And don't forget I had a 90-degree angle there. What is the measure of JHG? Well, we already did that one because it was perpendicular. It's the first thing I wrote. It's 90 degrees because it's a tangent to the circle. And finally, what is the measure of CJ? Hang on, let me just erase this stuff here. It gets a little muddy after a while. CJK right here. Well, this is, what was it again? 20? 20. This is 90. That makes 110. The remainder of 110 to 180 is 70 degrees. So therefore, since all three have to equal 180, that angle must be 70 degrees. Question 5. In the diagram, AB is tangent. Right away, AB, there's AB. And it's tangent to the circle, which means boom, right away. Before I start thinking, I'm going to put my 90-degree angle in. BD is the diameter of the circle. AB is 6 meters, and AD is 10 meters. Okay. And triangle BCE is an equilateral triangle. Well, that's good to know. So justify your answers to the following questions. What is the length of the diameter? So if I trace this out right here, and then bring it over, I have a right triangle. Two legs of which I know. I know these two legs. And this distance right here from these 2 points here is actually the length of D to B, which is actually the diameter. So if I solve it using Pythagoras, I get 100 over here, I get 36 over here. Now remember, the area of this square plus the area of this square equals the area of this square. So 36 plus what equals 100? Sorry, 100. I could take 100, take away 36 to figure out this is 64, which makes the diameter of the circle 8. So the diameter of the circle is 8 meters based on Pythagoras. The second thing is, what is the length of the chord BE? So what is the length of this chord here? Well, this is interesting because it doesn't really take a lot of thought. If the diameter is 8 meters, then that means the radius is 4 meters. And since it's an equilateral triangle, each of those will be 4. So therefore, what is the length of BE, this chord right here? The answer is it's 4 meters because it's the same length as the radius. What is the measure of the inscribed angle BED? So let's find BED. BED, right? B to E to D. There we go. So what is this measure right here, the whole thing? What is that whole angle right there? Well, B and D are connected to the middle forming a diameter, or the middle C forming a diameter. And we know that that's 180 degrees. D and B are also connected to point E, which makes E inscribed to the diameter, which means that the angle of that will be 90 degrees, or half of the 180 degree diameter. Okay? And finally, what is the length of the chord DE to the nearest meter? Let's take a look at this. So we know. So it's really asking, what is the length of this chord right here? Okay? And again, if I trace this whole thing out and brought it over here and rotated it, I have a 90-degree angle here because we figured out that it's inscribed. I know that this is 4 because it's this length right here. And I know that this is the hypotenuse, which is 8 because it's the diameter. And the chord is really x. So again, we have another Pythagoras question. I'm going to solve it with this here. I got 16 here. I get 64 here. 16 plus what equals 64? The answer is 48, I think. Right? So therefore, what is the length of x? It will be the square root of 48. And since the square root of 49 is 7, the square root of 48 we can surmise is 6.9. We'll take 48. Square root, it is 6.9. So therefore, what is it to the nearest meter? 7 meters, because we got to round 6.9 up to the nearest meter, approximately 7 meters. All right, question 6 says, in the diagram, FG is tangent to the circle at point G. So right away, this is tangent to the circle, which means I'm going to put a 90-degree angle right there. Didn't do any math, just read the first sentence, told me it was tangent, put my 90-degree angle, and now I see that there's a right triangle there that I'm probably going to have to use here eventually. GH is the diameter, and CJ, this one right here, is 5 millimeters. FG is 7 millimeters, and triangle CGJ is an equilateral triangle. So it actually took the opportunity to give you all this information and put it on there. What I would probably do is give you all of this information and give you just the drawing, but I would not put these in for you, and I would not put these in for you. You would probably have to do that yourself, right? You'd have to figure out the information to put that information in for yourself. So what is the length of the diameter? Well, right here, the first question, it gives you this distance as being 5. And since that is a radius, and we know the diameter is 2 radiuses, then the diameter has to be 10 millimeters. So this distance here, from here to here, which is the diameter, that distance has to be 10 millimeters because it's 2 radiuses. Is triangle GHJ a right triangle? Is GHJ a right triangle? So GHJ, is this a right triangle? And the answer is yes. And the reason why is because GH is the diameter, meaning it's connected to the middle, and it forms a 180 degrees line because it's a straight line. And G and H are also connected to point J, which makes J inscribed to the diameter, which means it is 90 degrees, and therefore, yes, it is because it's inscribed to the diameter. What is the length of the chord? Question C, what is the length of the chord HJ? So what is the length of this chord right here? Justify your answer. Again, we had this exact question, I think, in question 4. We have a right triangle right here, and I'm just going to draw it right here. We know that this bottom part of the right triangle is 5 millimeters because it is an equilateral triangle. And all of those are the same. This distance here is really the same as this distance here, which makes it the hypotenuse, which is 10 millimeters. And the chord that we're looking for, chord HJ, is really x. Slap on our squares. This is 100, this is 25. The area of this square plus the area of this square equals the area of this square, which means this square is 75, which puts the length of the chord, without rounding it, the square root of 75, or approximately to the 10th of a millimeter. Take my calculator. Square root of 75 is 8.7. Approximately 8.7 millimeters is the length of this chord here. Question number D, letter D. What is the measure of angle FGH? FGH. Again, we already did that. It's the first thing we did. It's 90 degrees, and the reason why is because of that sentence right there. And finally, what is the length of FH? What is the length of that line right there? Well, again, it's simply a right triangle again. The bottom is 7. This distance here is actually the diameter, which is 10. And the length of the chord is really the hypotenuse of that right triangle. Slap on some squares here. It's 100. It's 49. This will be 149 because it's the area of the two squares attached to the legs. The square root of 149 should be just a little bit more than 12. Maybe 12.2. Yes, 12.2. So therefore, the length of chord FH is roughly 12.2 millimeters. Question 7 says, a dog is tied on a leash to the clothesline pole in the backyard. The leash is 5 meters long, and the pole is a perpendicular distance of 5 meters from the edge of the house. So, this distance here is 5 meters. Okay? The distance of the back of the house is 16 meters. What is the distance from the pole to the cat door? So, the only information not given here, that the rest of the questions kind of did for you, is it didn't give you that black line saying the perpendicular distance of the pole to the back of the house is 5 meters. So what that really means is I can draw this information, and then I could connect the pole to the cat door. And when I look at this, I really have a right triangle with 16 and 5, and that distance from the pole to the cat door is the hypotenuse. So when I take these and put my little squares on here, 16 squared is 256, 5 squared is 25. Those are both legs of a right triangle, because this is a leg and this is a leg. So therefore, the sum of those two will be 281, because 256 plus 25 is 281. And therefore, the distance from the pole to the cat door will be the square root of 281, or approximately 16.8 meters. Approximately. Question number 8. Find the length of X in each diagram. So the first diagram, it's so easy. As long as you know line L is tangent to the circle, all you have to do is put a 90-degree angle in there. Redraw your triangle. This is 15, this is 8, this is X. Solve it with a quick Pythagoras. 225, 64, 289. The square root of 289 is actually a perfect square. It's 17. So therefore, the length of X is 17 meters from the distance from this point to this point. Question B, what is the length of X? This is a little bit more complicated. So again, it says it's tangent, so I'm going to put that 90-degree angle in. And before I go any further, I'm going to then say that what is this distance here? Okay? So I'm going to take my right triangle. I'm going to put 20. I'm going to put 16. I'm going to put X. Okay? And I'm going to put my squares on here. This is 400. This is 256. If I subtract those two, I get 144 here. So this X right here is really the square root of 144, which is 12. Now, if we look at this distance here, this is a radius. This is also a radius. This is also a radius. And so is this. So since the X here is 12, and this is also a radius, that X is logically also 12. Because Both of them are radiuses. So the answer for x is 12. The next question, question 9, says, what is the measure of angle omega? Or whatever that symbol is. It's not omega. What is that called? It's theta. What is theta? It's theta, kind of like Thanos, but different. What is the measure of theta in each diagram? Line L is tangent to the circle. So line L is tangent to the circle. I know that's my cue to do this. Okay? So here we have two lines intersecting. And right here, this line and this line are intersecting, with this being 55. Now, since this is a straight line, we know that this over here would be 125, because 55 and 125 make 180. And since this is a straight line, then this angle plus this angle has to equal 180, and therefore it has to be 55. And this is a straight line, so this angle plus this angle has to equal 180. So what we learned here is that when two lines meet, Paige, could you stop talking? Opposite angles across from each other will be equal in measure. So this will be 55 degrees. And since this is tangent, we can put a 90-degree angle there. And theta, therefore, is the remainder of the 180. So 90 plus 55 plus theta will equal 180. So 145 plus x equals 180. Now, if you want to solve it algebraically, you would simply subtract 145 from each side, the constant, and x will equal 35, or in this case, theta will equal 35 degrees. Question B, what is the measure of theta here? So, again, it's 90 degrees here. Since 90 plus 74 is the interior angles of this triangle, that is 164. This must be 16 degrees. And since this is a straight line, and this is 16 degrees, this plus this has to equal 180, which makes this one 164 degrees. So theta is 164. Question 10. Both circles are identical in size. They are tangent to each other at line L. So right now I'm going to put that and that in here. What type of quadrilateral is rock? Well, rock obviously is what they call a rectangle, because these are 90 degrees and they are 90 degrees up here. The measure will therefore be equal, and we will have a rectangle. If the radius of the circle is 5 centimeters, what is the perimeter of rock? All right, let's do this together. So if the radius is 5 centimeters, what is the perimeter? Well, this would be 5. This would be 5, this would be 5, this would be 5, and this, of course, would therefore make a rectangle that looks something like this, and the perimeter is the distance around it. Now, if you want to use a formula, we would have 2 lengths and 2 widths, or we'd have 2 10s and 2 5s to make up the perimeter, and therefore, the perimeter of the circle would be 30. 5, 10, 15, 20, 25, 30. So what's the perimeter of rock? The distance would be 30 centimeters. Question 11. Line segment AB. Now here's an example of one that we don't have anything drawn. Do you guys have something drawn on yours? No, right? Yes? No? Is there a drawing for this one? I have to draw the diagram. Okay. Well, while that was on pause, we had a wonderful conversation about life choices. And what we're going to do is we're going to quickly roll through question 11 here. And we're going to say, so line segment AB. So I'm going to draw a circle. And I'm going to draw line segment A. Sorry, that's not AB. AB is outside. AB is outside the circle. So we're going to AB. Sorry, AB. And it is tangent to the circle at point A. So that means I can put a 90-degree angle. If the diameter AD of the circle is 7.3, if the length of AB is 4.2, so I'm going to put 4.2 centimeters here, and I'm going to put this whole diameter, this whole thing, as being 7.3, which makes this radius and this radius half of 7.3, or 3.5, 3.65. This line right here, then, if the diameter is 7.3, then half of that will be 3.65. And it says determine the length of BD. So what is the length of this? Actually, hold on. My mistake. I do actually need the full radius. 7.3. So what we have here is a very simple question of a right triangle. 7.3 up here, 4.2 right here, and a 90-degree angle there. We're going to probably use the formula for this because it doesn't lend itself really well to drawing. So a squared plus b squared equals x squared, or c squared, or the distance of BD. 7.3 squared is 53.29. 53.29 plus 4.2 squared, which is 4.42, I think. Or sorry, 16, I don't remember. 17.64. Add those two together. So 53.29 plus 17.64 equals 70.93. So if I square root that, I get the distance of 8.4 right here. So the distance of D to B is approximately, rounded up, 8.4 centimeters.